Good day, everybody. And your favorite uncle is back. And today I am bringing you the November 2023 exam. I know that you are preparing for your May June exams. So if you have not subscribed, please just make sure that you do the right thing. And of course, Uncle Maswiti will do the right thing as well in bringing you good content. All right, let's get right into it. All right, so let's start with question 1. All right, so they say solve for x, and you know that this is a confidence builder, in any exam. So let's start with that. So they say to us we've got x squared. So 1.1.1, we've got x squared plus x minus 12. All right, so remember factors of 12 such that when you subtract them will give you 1. So that's going to be definitely 4 and 3, so that's x and x, that's 4 times 3. And in this case, remember the bigger product must give us the sign of our middle term, so 4x has to be positive in this case. So we've got x is equal to negative 4 or x is equal to 3, right? So that's the first one. Right, moving right along to the second question. So we've got 3x squared minus 2x equal to 6. Now remember, when they say to you answer correct to 2 decimal places, so it means that we are actually going to use our quadratic formula. So please keep that in mind all the time, right? So we've got 3x squared, right, minus 2x. Okay, I'm just going to bring the 6 to the other side so that it's in standard quadratic form, right? So we use our quadratic formula. So x is equal to minus b plus minus the square root of b squared minus 4ac, right? This is divided by 2a. So our b value, that's minus. Now our b value is negative 2, right? So substitute negative 2 there, right? Plus minus the square root of, okay, let's find the b value again. Negative 2 squared minus 4 times our a value is 3, positive 3, and our c value is negative 6, right? And all of this divided by 2 times our a value, which is positive 3. Now all that we need to do is just plug that into our quadratic formula, or rather calculator. So that's going to be 4 plus minus. Now inside the bracket, the square root there, right, you've got 4, right? In this case, let's try and get this as much as possible. So you've got 4 plus, now 6 times 4 would give us, so that's 4 plus, remember in this case, you've got negative times a negative, which would give you a positive, right? So you've got 4 times 3 times 6 there. Okay, so I get 76. Okay, so that's inside the bracket divided by 2. And of course, all that's left for us to do is just to find our factors. Now, in this case, I'm just going to simply put that in my calculator. So I've got 4 plus. Okay, so instead, let's do this. So I've got 4 plus the square root of 76. Okay, and this is divided by 2. Okay, so that will give me 6.36. Okay, please make sure that when you round off there, they said to 2 decimal places, right? And the other solution is x is equal to, all we do is change the positive into a negative. Okay, so we're going to say that's minus, and that would give us minus 2.36. Okay, right, and that is our final answer, right? Okay, so we've got that. So we've got our 2 solutions there. Please just verify just to make sure that I'm on the right track. Okay. Oh, actually, I made a mistake. That was supposed to be divided by 6. Okay, so that changes our answers there. So let's go to our calculator. That's supposed to be divided by 6 at the bottom there. Okay, so the one answer is negative 0.76 0.79 rather. Okay, and the other one would become, so that's plus, so that becomes 2.12, right? Okay, so that's 2.12. Apologies for that. Okay, so that is how we will get to the final answer. Right, and then the next question, right? We are solving now by squaring both sides, right? And in this case, what are we given? We're given square root of 2x plus 1 equals to x minus 1. So square root of 2x plus 1 equal to x minus 1. Right, so how are we going to do this? We are solving for x by squaring on both sides. Why are we doing that? We're trying to get rid of this of the square root, right? So we've got 2x plus 1 equal to, now remember, if I've got a square bracket, that's x squared minus 2x, so that's x times negative 1 times 2 for the middle term, right? So in this case, plus 1. Okay, let's try and get all the other hochakis to the other side. So we've got x squared minus, now if I take the 2x to the other side, it becomes negative 2x, that becomes minus 4x. And in this case, the ones actually can cancel out. That will be 1 minus 1, and that will give us 0. So if we solve this, that's going to be x into x minus 4, right, should be equal to 0. And so that means x is equal to 0 or x is equal to 4. Now, we need to go and check or test the solution so that we know which one is the actual solution, right, if both solutions are actually applicable. Right, so let's check if we substitute 0, right? So if I say the square root of 2x, remember you go to this portion where you actually squared both sides. So this would be 2 times 0 plus 1. Okay, so that would give me square root 2. Okay, that would be square root 2. Rather, that would be 1. Okay, so 2 times 0 would give me 0, and square root of 1 would be 1. And on the other side, I've got x minus 1. So remember, x is 0. So 0 minus 1 gives us negative 1. So there's no way that you can have a positive square root giving you a negative solution. So that means that x cannot be equal to 0. Okay, and then let's check when we substitute 4 into that. So if we say 2 times 4 plus 1, okay, that will be 9. And square root of 9 is 3, right? And on the right-hand side, I've got x minus 1, so that will be 4 minus 1, which is also going to be 3. And so that is actually a solution. All right, so awesome stuff. Please do not forget to always check the solution, right, and see if both solutions are applicable. All right, as we move on along. Okay, so that was 1.1.3 actually. Right, and then we've got inequalities. We've got x squared minus 3 greater than 2x. So that's 1.1.4. This was 1.1.3. Right, so we've got x squared minus 3 greater than 2x. So we need to find out, okay, how do we solve this? Of course, we get it into standard quadratic form first. So that's x squared minus 2x minus 3 greater than 0. Right, so let's factorize just to get our critical values. So we know this will be x and x. Factors of 3 are 3 and 1. And in this case, we know that the bigger product must give us the sign of the middle term. So our critical values, please don't forget, they change sign once they get out of the brackets, right? So our critical values are negative 1 as well as 3, right? So now, remember, this is actually a parabola, and this parabola means that it has x-intercepts at 1 and negative 1 and 3, that is, right? Now remember, this parabola would be positive, right, before negative 1, and it would be negative between -1 and 3, right? You can see it's below the x-axis, and it would be positive thereafter, right? So these are our critical values. Now we are not going to include these values, so I'm going to have open dots there, right? So what is our solution? Where is this graph greater than 0? So x would be an element. In fact, we can write it in inequality form as x is less than -1 or at x is greater than 3. Okay. Now, another way that you could write it is in element form. So x is an element of, right, you'd say -infinity. So keep that in mind, right? All the way up until -1, which is also excluded. Remember, round brackets means we are excluding, right? Also, this would be from 3 all the way to infinity. All right, and on to the next one. They say solve for x and y simultaneously, where we've got x plus 2 is equal to 2y, and 1 over x plus 1 over y equal to 1. Right, so let's start with the equations, right? So the first equation is a linear equation. Okay, so what do we have there? We've got x plus 2y equal to 2, right? And the other one, we've got 1 over x plus 1 over y equal to 1. Right, so what do we do first? Now, ladies and gents, I'm going to call this equation 1. And I'm going to call this equation 2, right? Now, from equation 1, please always keep in mind, ladies and gents, right, that what I ought to do is try to simplify the equation as much as I possibly can, right? So if I'm given x plus 2y there to be equal to 2, let's make this, actually it's x plus 2 equal to 2y. Sorry about that. Right, x plus 2 equal to 2y. So let's make x the subject of the formula. So from equation 1, I'm going to make, please try to avoid fractions as much as possible, right? Of course, there are instances, very seldom, where you cannot avoid fractions, but please do avoid them as much as possible. Right, so now we've got x is 2y minus 2, right? So that will be our equation 3. Now, from equation 2, what we could have done, or in this case, let's just substitute equation 3, substitute equation 3 into equation 2. Please remember, when you substitute, I substitute into the equation that I did not manipulate from, right? So this will be 1 over, everywhere I see x, I'm going to substitute 2y minus 2. So this 1 over 2y minus 2 plus 1 over y, this is equal to 1. Now, remember, what would be our LCD, right? Our LCD, in this case, lowest common denominator, will be y times 2y minus 2. So remember, I'm going to multiply every term by the LCD. So I'm going to say, all right, so for the first term, right, this guy here, I'm going to say y times 2y minus 2, my LCD, multiplied by that term. So that's 1 over 2y minus 2. Okay, so yeah, it just looks clumsy there. Okay, let's just write it a bit nicer. Okay, so this is plus 1 over y times our LCD, y into 2y minus 2, which is equal to, we've got 1 on the right hand side, multiplied by our LCD again, y into 2y minus 2. Okay, right, I've squeezed myself too tightly there. All right, so what happens? This guy cancels with that. On the first term, I'm left with just y. And then on the second one, the y's cancel, right? So I'm left with 2y minus 2. And on the last term, the one on the right-hand side, 1 times all of that becomes all of that, right? So that will be 2y squared minus 2y. All right, now let's try to simplify as much as we possibly can. So I'm going to leave this that side. I'm going to take the 2y to the other side. In fact, I've got 3y on the right-hand side, right? That's y plus 2y. So I'm going to have 2y squared, right? Minus 2y minus 3y will give me minus 5y. Okay, and we've got that constant term, which is minus 2, but that has to be now plus 2, and this will give us 0. Okay, right, so can we factorize this? Absolutely. So that means I've got 2y and y here, right? And I will have 2 and 1 over there. Now note in this case, I want both of them to give me 5. So that will definitely do the trick, right? So what's our solution? So y is equals to 1 over 2, or y is equal to 2. So now we can find the value for x. And remember, what did we say? X was equal to 2y minus 2, isn't it? So x will be 2 times our y value is 1 over 2 minus 2, or x will be equal to 2 times 2 minus 2. Okay, so we've got 1 minus 2, so x will be negative 1, or x will be equal to 4 minus 2 will also give us 2. All right, so that is how we solve for that simultaneously. Very interesting question. Right, and off to the next one we go. Right, so we've got, given that we've got that expression 2 to the exponent m plus 1 plus 2 exponent m, right? And we've got 3n plus 2 minus 3n, where m and n are integers, right? So they say determine the values of m and n. Right, so ladies and gents, we're going to solve there. Okay, so that's 1.3. We've got 2 exponent m plus 1 plus 2 exponent m equal to 3 exponent n plus 3 minus 3n. All right, now what do we do? Right, we realize that on the left and on the right hand side we've got different bases. So I'm going to take out a common factor. Now remember, when I've got 2m plus 1, this is the same as 2m times 2 to exponent 1, right? 2 exponent m times 2 exponent 1. Remember, the laws of exponents. Bases are the same, and I'm multiplying. I add the exponents, right? So this will be 2 exponent m. And so the next one becomes 3 exponent n, right? I think I wrote that. Did I write it correctly? Is that 3n plus 3? I think it was 2, right? Yeah, it was 2. Okay, so n plus 2. So this would be 3 times 3 squared minus 3 exponent n. And I'm sure you can see how we can actually take that out as a common factor. So what does this become? So that becomes 2 exponent 1, right, plus 1 if we take out the 2m. And on the right hand side, we've got 3 exponent n. So I'm left with 3 squared minus 1 as well. Right, so what does this give me? 2 exponent m times 3, which is equal to 3 exponent n, right? 3 squared is 9 minus 1, that gives us 8. Okay, right, so let's write this as, let's bring all the coefficients, or rather the ones with the variables on the one side, right? And I'm going to divide by 3 here, divide by 3 over there, right? So that cancels with that. So on the left hand side, I've got 2m over 3n is equal to 8 over 3. Now, can I write 8 as a base of 2? Absolutely. So this is 2 exponent 3 over 3 exponent 1. I'm sure you can see where I'm going with this, right? So what does that mean? It means that m, right, bases are the same. It means that the exponents are the same, right? So m is equal to 3 and n is equal to 1. And the instruction was find m plus n. So m plus n would be equal to 4. Okay, right. And that is how our first question comes to an end. All right, let's go on to question 2. And on to question 2 we go. Right, so we're looking at sequences and series. They say given the arithmetic series 7, 12, and 17. Right, they say determine the value of T91. Now remember, in an arithmetic sequence or series in this case, right, so first of all, we know what our A value is, right? Our A value will be 7, right? And our D value in this case, we can say T2 minus T1, and that would give us 12 minus 7. That should be 5, right? So we know our A value and our D value. So we're looking for T91. So remember that Tn is equal to A plus n minus 1 times D, right? So we're looking for T91, and that's going to be 7 plus 91 minus 1 multiplied by 5. Okay, so we just whip out our calculator quickly. So this is going to be 7 plus 91 minus 90, and minus 1 rather is 90. So that's 90 times 5. And that gives us 457. Right, such questions, guys, don't even waste time on them. We move on to the next one. They say calculate the value of n for which Tn is equals to 500. Oh, actually, I skipped a question. They're looking for S91, right? So in this case, if we're looking for S91, right, so I'm going to do this in the easier version of the sum formula. That's n over 2 into A plus L, right? Okay, so this is the formula that we use when we've got the last term. And where do we have the last term? We know it. It's T91, isn't it? Okay, so this is going to be 91 over 2. Our A value is 7. And our D value, or rather last term rather, is 457. Right, so again, quickly, to whip out our calculator, that's 91 over 2. Okay, this is going to be multiplied by 7 plus 457. All right, we close that, and that means the sum of the first 91 terms will be 21,112, right? Of course, nothing wrong if you decided to use the other formula, right? Well, the one that is usually given. So it says n over 2. This is going to be 2a plus n minus 1 times d. Okay, and of course you've got your n value, you've got your a value as well as your d value. You can substitute and check if it gives you exactly the same answer. Right, so that was 2.1.2. I need to indicate that there. That's 0.1. Right, let's go on to the next one, 2.1.3. They said find the n value, calculate the value of n for which Tn is 517. Right, so Tn is equal to 517. Okay, so what we're going to do is say, well, we know what A is. That's A plus n minus 1 times D is 517. Our A value is 7. N minus 1, in this case, multiplied by 5, okay, is 517. Okay, so we're going to Right, I'm going to take the 7 to the other side. Okay, so that means that 5 into n minus 1 is equal to, right? So if I take the 7, 517 minus 7 gives me 510. Okay, and I'm going to divide by 5, right? So divide that by 5. So that should give us, all right, so that should give us, that will be 510. My mind is just not working right now. 102. I could have guessed that on any other day, but I'm not sure. Is not make sure about my mind right now. So n is equal to, now if I take the 1 to the other side, that becomes 103. Okay, so that will be the 103rd term will be equal to 517. Right, so let's go on to the next one. So they say to us, the following information is given about a quadratic pattern, right? So they give you a quadratic pattern there, and they say to you, first of all, term 1 is 3. They say term 2 minus term 1 is 9. Okay, so I want you to think about it. So they give us the first term to be 3. Okay, actually, let me write it down at the bottom there. Right, so that's 2.2, right? So they say the first term is 3. Okay, but now they give us the first difference. So they said term 2 minus term 1 is 9. Okay, so this is the first difference. They say this is equal to 9. And of course, I mean, we can find the next term of the sequence, right? 3 plus 9 should give us 11, right? 12 rather. So that should give us 12. So which means the next term of the sequence should be 12. Right, and then term 3 minus term 2, again, they're giving us the first difference. This is equal to 21. So they're saying term 3 minus term 2 gives us 21. So which means if we wanted to also find the third term of the sequence, we just say 12 plus 21. In this case, this should give us 33, right? Okay, and they say to us, show that T5 is 111. Okay, so quite easy to note there. So we've got term 1, term 2, and term 3, right? And what would be our second difference in this case? And remember that the second difference is always common, right? So we're going to say 21, right, minus 9. Okay, so in this case, this should give us 12. Okay, my voice is just doing some funny stuff there. Right, so that should give us 12. So in this case, it means our second difference is 12. So remember that becomes a common difference, right? So that means I'm going to say 21 plus 12. What should that give me? That should be 33, right? Okay, so that should be my next sequence of my first difference. And so that should give us our next term. So 33 plus 33 would give me 66. That's the fourth term, isn't it? Right? But again, what am I going to do? I'm going to add another 12 to the 33, right? So in this case, I'm going to add another 12 there. What does that give us? That gives us 45. Okay? So if I add 66 plus 45, definitely that should give me 111, right? And that is term 5. All right, so we've shown that term 5 is 111. Okay, they say show that the general term of the quadratic pattern is Tn is equals to 6n squared minus 9n plus 6. All right, now remember we now have our first and second difference, our first difference and second difference. We know that in a quadratic sequence, our first difference is equal to 3a plus b. our second difference is equal to 2a, and our first term is a plus b plus c. Right, let's find our a value first. So 2a is equal to 12, divided by 2 on either side. Okay, so a will be equal to 6. Right, and then what about our b value? That will be 3a plus b is equal to 9. So that will be b is equal to 9 minus 3 times. We know what our a value is. Our a value is 6. Okay, so that's 9 minus 18. So that should be minus 9. Okay, right, so that's our b value. And our c value, we always say a plus b plus c. That will give us the first term, right? The first term of our sequence is 3, right? Our a value is 6 minus 9, okay, plus c is equal to 3. And so our c value, so that will be negative 3. Take it to the other side. Our c value is equal to 6. So in this case, it means that the nth term of the sequence is going to be 6n squared minus 9n plus 6. Okay, so that is exactly what they had asked us to prove, and that's how the cookie crumbles. As they show that the pattern is increasing for all n element of natural numbers, right? Now, if you look at this, right, how do we show that this is an increasing pattern? Right, so what I'm going to do is I'm going to try to complete the square, right? So in this case, we can do this. How do we do so? You can find minus b over 2a, right? So in this case, what does the minus b over 2a give us? Right, so that would be minus the negative 9 divided by 2 times 6, okay? So that will be 9 divided by 12. Okay, so that's 9 over 12. So that would have been, if we're looking for the turning point, okay, that would be the x value of our turning point. In fact, we can actually simplify this a little bit more. So 3 into 9 goes 3 times, and into 12 4 times. So that will be 3 over 4, right? Okay, so if we're looking for Tn, okay, the y value when n is 3 over 4, okay, so we're going to say 6 into 3 over 4 squared minus 9 times 3 over 4, okay, plus 6. This is just me being lazy to complete the square, right? So this is another way of kind of cheating the system, right? So this is 6 into 3 over 4. And remember, this is squared. Okay, that's minus 9 into 3 over 4. And again, that's plus 6. Okay, so that gives us 21 over 8, right? Now, ladies and gents, what I'm simply going to do is I am going to write this sequence or this pattern in this manner, right? So this would be equal to 6 into n minus, now note this is 3 over 4, right, squared plus 21 over 8. Okay, so notice I have written it in the form a is equal, a into x minus p all squared plus q, right? Now if you look at this, inside here, for all natural numbers, it will always be positive, isn't it? Okay, so in this case, you can see that for all n is an element of natural numbers, right? N minus 3 over 4 will always be greater than 0, right? So there is no subtraction here, so it will, therefore Tn will increase. Tn will increase for all values of n is an element of natural numbers, right? So for whatever natural number that I use there, I will always have an increasing function. All right, ladies and gents, that is how the cookie crumbles. Let's go on to the next question. And question 3 says, given the geometric series, all right, 3, 6, and 12 to the nth terms, they say write down the general term of this series. Okay, just like the arithmetic sequence or the arithmetic series, we need to know what our a value is. Our a value is 3. Right now, remember that the common ratio for a geometric series, in this case, we simply say T2 divided by T1, or any term divided by the preceding one. So we're going to say that 6 divided by 3, and that also gives us 2. Okay, so in this case, we know that our common ratio is 2. So the nth term is always a Rn minus 1, right? So this is going to be 3 times 2 to the n minus 1. Now remember that we can also write this in this manner. So this would be 3 times, so that's 2 to the exponent n multiplied by 2 to the minus 1. Now remember, 2 to the minus 1 is the same as writing it as 1 over 2, right? So we're multiplying this entire thing by 1 over 2. And so what it can actually become is 3 over 2 times 2 exponent n. All right, so that's another way of writing that whole thing down. Right, so 3.1.2, let's say calculate the value of k such that the sum, okay, so they're giving us the sigma notation, the sum of 3 over 2 to the multiplied by 2 exponent p from p is equals to 1 all the way to k, right, will be equal to 98,301. All right, so we've got the sum of the nth term, right, or the sum of k terms in this case. So I want you to please note, do you see that what we've got there actually looks exactly like we have here? So not only do we know what our first term is, right, if we substituted it there, right, if you said p is equal to 1, or let's rather do it. So if you said, so that would be 3 over 2 into 2, right? So if you said that your k value, or rather your p value is 1, okay, so your p value would be 1, so your a value would be 2, right? And of course, just like I showed you in the previous one, our r value, rather our a value is 3, and our r value is 2. Okay, now we are looking for the sum of the terms. So remember, for a geometric series, right, Sn is equal to a into r exponent n minus 1 divided by r minus 1, right? But we know this should give us 98,301. Now we need to first see, in this case, we're starting from p is equals to 1 all the way to k, and we're looking for the value of k. Now remember, when you are taking a sigma notation, right, so what are the number of terms in this case? You'll always say the upper boundary minus the lower boundary plus 1. So that's k minus 1 plus 1, right? So in this case, it means that we are looking for the sum of the k terms. So sk, so which means our n value will be equal to k. So I'm just going to substitute there. Our a value is 3. That's 2k minus 1 over r is 2 minus 1, and this should equal to 98,301. Right, let's try and solve there as quickly as possible. 2 minus 1 is 1, so I end up with just 3 into 2 exponent k minus 1 equal to 98,301. And if I divide by 3 on either side, right, so please, I want you to note what is 98,301 divide by 3. I've got 32,767, and this will give us 2 exponent k minus 1. And if I take the 1 to the other side, 2 exponent k is equal to 32,768. Okay, right, so you can change that base into base of 2. Let's see, if we said 2yx 13, okay, so definitely bigger than that. If we said 14, okay, so I suspect it's the next one then. If we said 15, right, 768, so this is 2 exponent k. This would be 2 exponent 15. Bases are the same, right? So we can drop the exponents. So k would be equal to 15. Right, and that's how the cookie crumbles. Otherwise, you would have had to introduce logs, and you can get that using logs. All right, so I took the chance there. Okay, 3.2. Right, moving to the next one. They say a geometric sequence and an arithmetic sequence have the same first term, right? They say the common ratio of the geometric sequence is 1 over 3. Okay, so let's write down. So for the geometric sequence, r, they said, is equal to 1 over 3. And they say the common difference of the arithmetic sequence is 3. So for the arithmetic sequence, okay, they said d is equal to 3. Right, and then they say to us the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence, right? So let's write down the sum of the 22 terms, and let's write down the sum to infinity. Right, so sum of the first 22 terms for the arithmetic sequence, right? So remember, we know this is going to be n over 2. We said this is 2 times a plus n minus 1. Okay, so that would be 22 minus 1 times d, and we know what our d value is, right? So that's 22. Okay, let me just keep that as n because I had not substituted as yet. So this is 22 times 2a plus 22 minus 1 will give me 21 multiplied by, remember the d value is 3, right? So 22 over 2, that gives us 11 into, this is 2a plus 21 times 3 will give us 63, right? So the sum of 22 terms, this is for the arithmetic sequence, right? And then the sum to infinity for the geometric sequence. Now remember, that's a over 1 minus r. Okay, so sum to infinity, we don't know what the a value is, but remember they said the first term is the same for both of them, so I'm going to leave that as a. So that's 1 minus 1 over 3, right? So remember 1 minus 1 over 3 gives us 2 over 3, right? So we've got a divided by 2 over 3, right? So if I don't want to have a fraction at the bottom there, I will multiply by the inverse, 3 over 2. But what I do at the bottom, I do at the top as well, right? So that cancels that with that. So we've got 3 over 2a. So the sum to infinity will be 3 over 2a. Now remember, what did they say to us? They said the sum of the 22 terms, right, of the arithmetic sequence is 734 more than the sum to infinity, okay? So which means, in this case, the sum to infinity plus 734 will give us the sum of the 22 terms, okay? Or otherwise, all right, let me not confuse you too much. So remember what they're simply saying, the sum to infinity of the geometric sequence would be, or rather plus 734, right? That's what we had, right? 734, absolutely. Right, so the sum of the 22 terms, right, is 734 more, right, than the sum to infinity. All right, so now we can find the two together, right? So which means that sum of the 22 terms minus sum to infinity should give us 734. So then let's try and work that out. So we've got 3 over 2a plus 734 will be equal to 11 into 2a plus 63. Okay, right, so let's try and so this would be 22a, right? That's 11 multiplied by 2 plus, right, 63 times 11 would give me 693, right? And what will this give me? So this is 3 over 2a plus 734. Right, let's try and work it out as much as we possibly can. I'm going to bring this to this side, that to that side. So we've got 22a minus 3 over 2a. So that's 22 minus 3 over 2. Okay, that gives me 41 over 2a. So 41 over 2a is equal to, now I'm not going to waste a lot of time on the algebra part. So that's 734 minus 693. Okay, and I get 41. Right, ladies and gents, of course, what am I going to do? Right, I'm looking for the value of a, so this will be 2 over 41 multiplied by the inverse. That's 2 over 41. What I do on the left, I do on the right. And everything cancels out over that side. So a will be equal to 2. All right, so that is how I get my a value. They said calculate the value of the first term, right? And I did exactly that. Ladies and gents, that is how the cookie crumbles in this section. Let's go on to the next section. Right, and we start with question 4. They say sketched below is the graph of f of x, which is 2x minus 4. For x is an element of negative 2, which is included. Can you see it's got that black dot there, right? So it's telling you our graph is starting from that point and then all the way till 4, but 4 is excluded, so which means that's not part of the graph. The graph does not exist essentially at 4. Right, they say write down the equation of the asymptote of f. Now remember, in this case, this is, okay, an exponential graph. So an exponential graph normally has an asymptote at y is equal to 0, right? So this time around, we shifted it 4 units down. So that means that the equation of the asymptote would simply be y is equal to negative 4. All right, so they say determine the coordinates of B, right? So I'm going to write it at the bottom there, 4.2. So coordinates of B, remember what's happening at B. I know that y is equal to 0, right? So that means that for my graph, or let me rather say, so this is where f of x, right, is equal to 0, okay? Right, f of x is equal to 0. So now what happens? So in this case, I'm going to have f of x equal to 0. So that's 2x minus 4 is equal to 0. So that means 2 exponent x is equal to 4. And you can see 2 exponent x, that's 2 squared. Okay, so that means that x is equal to 2. So the coordinates of B in this case would essentially be, B would be 2 and 0. Okay, so that is our x-intercept. So we know that y is equal to 0 there. Right, so they say determine the equations of k, right, a straight line passing through A and B. Right, so A rather is the y-intercept of our graph, and we know that our y-intercept in this case, this is where x is equal to 0, okay? Now, if we take our y-intercept, I want you guys to note, so I'm going to take 4.3 over there. So if I say f of 0, so this is where x is equal to 0. This will be 2 exponent x, but our x is 0, minus 4. So that will be, anything to the power 0 is 1. So that's 1 minus 4, which gives us negative 3, right? So which means the coordinates of A are 0 and negative 3. And B, we remember, that's 2 and 0. So we're looking for a straight line that would pass through those 2 points, isn't it? Okay. So first of all, we'll find the gradient of that straight line. So M is y2 minus y1 over x2 minus x1, right? So I'm going to take my y2 over there. So that's negative 3 minus 0, that's my y1, 0, divided by x2 would be 0 minus 2. So in this case, it means that we're going to have negative 3 divided by negative 2. That would be 3 over 2. Now, I want you guys to note, they said we must write it in the form k of x, right? So, do you agree with me that A would also be the y-intercept of that graph, right? Because it would be passing through A and B, right? So A would be the y-intercept, and we know that A is minus 3. So which means k of x would be equal to 3 over 2x minus 3. Okay, so that is our equation for k of x. All right, now go off to the next one. Right, so 4.4 rather, they say calculate the vertical distance between k and f at x is equal to 1. All right, so we've got the vertical distance. So we are looking at the y values. So we're saying k at 1, okay, minus f at 1. All right, so let's take that. So we're going to say this is going to be 2, right, exponent 1 minus 4, right? Rather, let's start with k rather. So that's going to be 3 over 2, 1 minus 3, right, minus f at 1. So I'm going to put this in brackets. Okay, so let's do this. That's 2 to the 1 minus 3, minus 4 rather, 2 to the exponent x minus 4, right? So in this case, what am I going to do? So 3 over 2 minus 3, okay, so that's 3 over 2 minus 3. Now note, inside my bracket, I've got 2 minus 4, which is negative 2, but plus, multiplied by that negative in that case, so that would be plus 2 over there. So 2 minus 4, which will be negative 2, times the negative there, that becomes positive 2. All right, so let's try and work that out. So essentially, that's 3 over 2 minus 1, okay, and which will give us 1 over 2. Okay, so the distance between the two graphs at 1 is equal to a half. Okay, right, that is the vertical distance between the two. So remember, all that you're doing when you're finding the vertical distance is take the difference between the two graphs. Okay, right, at that particular point. 4.5, they say write down the equation of g if it is given that g of x is f of x plus 4. So g of x, they said, is f of x plus 4. Now remember, what would g of x be? Right? 2 exponent x minus 4 plus 4. And so what happens? This cancels out, so that tells us that g of x is essentially 2 exponent x. Okay, right, that's the equation for g. Now they say to us, write down the domain, right, of g, the inverse of g, right? Now, remember in this case, so we are looking at an exponential graph, right? So remember that if we're looking at the exponential graph, so for this guy here, which was f, all right, so the domain, or rather the range for this guy, let's see. So if we took it from there, from 2, okay, all the way till 4, I don't know if they want us to still use the same, the same restrictions that they have given, right? But in this case, if I'm looking at it, if we say, right, for the domain of this guy, we're looking at it between 2 and 4, right? So 4.6. So remember, so I'd look for g of 2, right? Negative 2 rather. Our graph starts, yes, that's negative 2 all the way till 4. G of negative 2, what will it be? So 2, so that's negative 2, 2 minus 2. So this will be 1 over 4. And what about g of 4, right? So this will be 2 exponent 4, and this will be 16. So what becomes our range of the graph of g, remember this now becomes the range of the graph, right? Okay, so that means that y would be an element of. Now remember, at minus 2 the graph existed, so which means we will have 1 over 4, right, all the way up until 16, right? The graph would be 16. That would be the range of the graph of g, right? But remember, in fact, this would not be included because the graph doesn't exist there, right? Now, remember, in this case, what did we do? Whatever is the range of the original graph, right, becomes the domain of the inverse, right? So which means now the domain of the graph of g minus 1, the inverse, is x is an element of. Now note, in this case, that would be from 1 over 4, right, to 16, right? And that would be excluded. All right, I hope that makes sense, guys. Right, if we were just talking about an exponential graph, right, remember that for any exponential graph, if we're looking at the domain, by the way, the graph of the inverse would be, in this case, a log graph. Okay, so if you think about it, for the domain of a log graph, it would always start at x is equal to 0 all the way to infinity, right? But in this case, because we're given restrictions, it will start at 1 over 4. I hope that makes sense, guys. Right, now the next one, they say write down the equation of g minus 1 in the form y is equal to. All right, so we did say, so you've got the graph of g. Let's write it in the form y is equal to. So this is g. Y is equal to 2, or rather, yeah, we said 2 exponent x. And so for g minus 1, the inverse, we just swap the x and the y. Okay, and what do we do? Right, so we introduce logs on both sides is equal to log of 2 to the exponent y. Remember, jump down rule. So that would be log x is equal to y log 2. Okay, and if we divide by log 2 on both sides, okay, that becomes simply y is equal to log. Now remember, this becomes base 2 of x. All right, so that's how you write it. I'm just showing it to you, but you didn't necessarily need to show it, but just write the equation. All right, ladies and gents, that is how the cookie crumbles. Let's go to the next section. And so we begin with question 5. So they say the graphs of f of x, which is minus 1 over 2, x minus 1 all squared plus 8, and g of x, d over x are drawn below. A point of intersection of f and g is B. The turning point of f, the graph of f has an intercept at -3 and 0, as well as at 5 and 0, and a y-intercept at C. Now, first of all, ladies and gents, I want us to note there, they've written the equation of this parabola in that form, right? And we said once it is written in that form, it means they've already given us the values of the turning point. So I can already just slot that in there. So it means our turning point will be at 1. Notice it changes sign from the bracket, but my value 8 remains as is, right? So we know that that value B should actually be 1 and 8. Okay, I hope that makes sense. Right, now they say to you, write down the coordinates of the turning point. Well, we've already taken the liberty to do that. That's 1 and 8. Okay, so that's where B is. Right, so let's go on to the next question. They say, calculate the coordinates of C. Now note that C is the y-intercept. Okay, so this is where x is equal to 0. So I'm just simply going to take there for 5.2. We're going to consider f of x. So let's write down the equation. So this is minus 1 over 2. That's x minus 1 all squared. We said plus 8. But for the coordinates of C, we're going to take f of 0. That's minus 1 over 2. 0 minus 1, which will be -1 squared, plus 8. So what should that give us? So we've got 8 and minus 1 over 2, right? So -1 squared will be 1 times -1 over 2 will be -1 over 2. And so that will give us 7.5, or we can say that will be 15 over 2, right? So that value there should be 15 over 2. So the coordinates of C will be x is 0 and y is 15 over 2. All right, happy days. Next question, they say calculate the value of d. Right, note that d is, in this case, the coefficient or the constant in that hyperbola. Okay, so g of x, all right, we know that it intersects, or rather that's 5.3. So g of x is d over x. But we already know that when x is 1, y is 8, right? So 8 would be equal to d over 1. So that means our d value will be equal to 8. So the value, or rather the equation g of x, will be equal to 8 over x. All right, and off we go to the next question. They say write down the range of g. Now note, we are talking about the hyperbola, right? So in this case, we are looking, when we're talking about the range, okay, we are talking about where it exists on the y-axis, right? Now notice that it means that our y asymptote is 0, right? So we will therefore say that that's y is an element of real numbers, however y cannot be equal to 0. So remember that our the value of our horizontal asymptote rather is 0 in this case, as I've indicated there. So it therefore means that it cannot be equal to 0. Okay, right. So the next question says we need to now find, sorry, that's 5.5. Okay, so 5.5 says, for which values of x will f of x multiplied by g of x be less than or equal to 0? Now, very interesting. These questions, I know that they tend to give you guys a little bit of a hassle. Now, remember, if I'm looking for something that is less than 0, right, what does it mean? It means that it is negative. So in this case, that can only be when the signs are different, right? So let's start with the first one. Let's look for the possibility where the graph of f is positive and the graph of y is negative. So let's go there, right? I'm going to just indicate with the different colors, right? So where the graph of, so both graphs here, this one is negative over there. This one is negative up until 3, but then what happens? It starts becoming positive from 3. Okay, so I want where the signs are different for both graphs, right? And what about the graph of y? The graph of y is positive all the way there. Okay, right, so where are the signs different on the graphs? Okay, I see that the graphs have different signs. Notice in this case, it will be from 3, I start having the graph of f becoming positive and the graph of y being negative. Can you see the signs are different all the way there? Right, so that would definitely be less than 0, right? Up until I get to 0, right? And again, where are the signs different? And this is from 5 all the way to infinity. See, from 5, this one starts becoming negative and the other one positive, right? So I'm going to say, well, this is from 3 to 0, right? And the other solution is from 5 to infinity. Okay, right, so that would be x is an element of, now notice they said less than or equal to, right? So x is an element of -3, and I'm going to include it there because if I took the product, it would be equal to 0 at -3, right? They said less than or equal to. So from -3, right, all the way up until 0. But remember, the graph of G does not exist at 0, right? So this will be all the way till 0, which is excluded, okay? But again, it begins at 5, right? They start becoming, having opposite signs. So from 5 all the way to infinity. Okay, so from 5 to infinity. Right, remember that infinity is never included, right? So another way I could have written this is that x should be less than 0, but it should be greater or equal to -3, or x should be greater or equal to 5. Okay, and that is how the cookie crumbles, ladies and gents. Right, so we're looking for less than 0. Right, let's go to the next question. They say calculate the values of k so that h of x, right, is equal to minus 2x plus k will not intersect the graph of G. Now, what happens when the two graphs intersect? It means that I would have h of x equal to g of x, right? So in this case, it means that for them to interact, I'd have them being equal. And if I find the roots, it means I'll find real roots in that case, right? So now I'm going to say, right, so if we look at where would they intersect, it would be where, rather, g of x is equal to h of x, right? And what is our g of x value, graph rather? That's 8 over x. And our h of x, they said this is minus 2x plus k. Right, I want us to try and write this in standard quadratic form. So I'm going to multiply everything by x, right? So multiply throughout by x. So this would be 8 is equal to minus 2x squared plus kx. All right. So if we take the 8 to the other side, that would be minus 8, right? So minus 8, this is equal to 0. Okay. So I'm going to say, right, for this graph, all right, it means that I am going to take the values, or rather, I want for this graph to have non-real roots because I don't want the graphs to intersect. They said to me, right, will not intersect. So for that graph, the delta value must actually be less than 0. Okay, so that means I'm going to take b squared minus 4ac, and this must be less than 0. So I want you to note in this case that will give me k squared minus 4 times our a value is -2. Our c value is -8, and this should be less than 0. So this would be k squared minus, that's 4 times 2, which is 8. 8 times 8 is 64. Hey, let's not make that mistake. Right, and so what this gives me is that k, right, so please remember, so that means this is the difference of two squares, right? K minus 8, k plus 8 should be less than 0. Now, if you think of it as a parabola, ladies and gents, right, inequalities, so that means that I've got -8 and 8. And notice in this case, it means that I am going to have, where is this graph actually negative? It would be, so that's plus, minus, plus. So that would be between -8 and 8. And remember, we're going to exclude those values because we are looking for strictly for it to be less than. So which means that k must be an element of -8 to 8. All right. I hope that makes sense, guys. Right, so let's go on to the next one. All right, so they say to us, h is a tangent to g, right, at r, right, a point in the first quadrant, And we now need to calculate t such that y is equals to fx plus t intersects g at r. Now, first of all, they said h is a tangent. What do we know about a tangent, right? That the derivative of g, right, at whatever value, at value of r, at x is equal to r, or at the x value of r, we are going to get the gradient to be equal to -2. Remember, the gradient of h is actually -2, right? So now this tells me that this must be the point where the two are going to actually intersect, right? Right, so which means let me take the derivative there. We've taken 5.6, so 5.7. So g of x is 8 over x. Now what would be g prime? Right? So remember, if I write it as in exponential form, that's 8x minus 1. So if I take the derivative, that would be minus 8x minus 2, right? So we can write this as 8 over, -8 rather, over x squared. And they said, well, in this case, the gradient should be equal to -2, which is the gradient of h, right? So that means I've got minus 8 over x squared is equal to -2, right? And if I try to cross multiply, I've got -2x squared. Okay, remember this is over 1 and I'm cross multiplying. -2x squared is equal to -8, and divide by -2 on either side. Okay, I've got x squared is equal to, right, that's x squared is equals to 4, and so x is equal to plus or minus 2, right, the square root. Now, note, ladies and gents, they had said to me that this point must be in the first quadrant. So which means k cannot, or rather x cannot be equal to -2, right? So in this case, x is equal to 2, right? And x cannot be equal to -2. So there is my x value, right? Now, what would be the corresponding y value in this case? Well, I'd get the y value, the corresponding y value, by taking that value there and substituting it. Now note, I'm going to substitute it into the graph of g because it should be equal to the graph of g, right? That's what they said to us. When we've got a tangent, it means h and g touch each other, right? So what should be our corresponding y value? That should be g of 2, okay, which is 8 over 2, and this should be equal to 4. Right, so which means the point R should actually be 2 and 4, and definitely that's in the first quadrant, right? So we wanted the value of t such that y is equal to f of x plus t, right? So now we know what x can be, we know what y is at that point R there, right? So when y, okay, let's first write down f of x. So that's minus 1 over x minus 1 squared plus 8 plus t. So we know when y is 4, right, x is 2 squared plus 8 plus t. Okay, let's find the value of t there quickly. That's going to be 8 minus 7. Okay, that's going to be 7.5. Okay, and that's 4 plus t. So that's 8 minus a half there. And so our t value will be equal to negative That's 4 minus 7.5. That should be negative 3.5, or we can say negative 7 over 2. Okay, so that is how I will get the value of t over there. Right, ladies and gents, and that is how the cookie crumbled. Yes, the last questions were a little bit of a workout, but nonetheless we got to the right answer. Let's go to the next question. And off to question 6 we start. So they say Patrick deposited an amount of 18,500 into an account earning R% interest per annum compounded monthly. They say after 6 months his balance is 19,319 and 48 cents. Right, so they want us to calculate the value of R. Right, let's get right into it. So we know we are looking at compound interest formula here. Right, so we know that A is equals to P 1 plus I. That's going to be to the exponent n. Right, so we know that our accumulated amount would be 19,000. So that's 19,300. Okay, so let's just write that nicely. 19,319 and 48 cents. And the principal amount was 18,500, right? But we know in this case this would be 1 plus. Now remember, this would be on a monthly compound interest, so that's I over 12, right? And in this case, that would be n times m, so that's half of a year, right? So that's 0.5 times 12, so that would actually give us those number of months either way. Right, so in this case, we're simply going to divide. So firstly, let's divide by 18,500. Okay, so what we do on the left, we'll do on the right-hand side. Okay, that cancels with that. And what I'm going to do is I'm going to take the 6th root, right, of that, so that we actually have I plus, or rather 1 plus I over 12. Okay, and obviously what we do on the left, we have to do on the right. I'm going to take the 6th root of that and start calculating the value of I. Right, so let's start there. Okay, I'm going to say shift. Okay, I'm going to take the 6th root of, right, let's put that in brackets. So that is 19,000, okay, 319 and 48 cents, and we are dividing that by 18,500. Okay, right, we get that value 1.007 okay, and we are going to subtract, right? Remember, we've got this 1, right, over here, so I'm going to take it to the other side. That becomes minus 1. So this entire thing, okay, oops, right, let me say answer minus 1. Okay, so we got this value, right? So remember, we've got I over 12, right, would be equal to that entire value. So which means to get the value of I need to multiply that by 12. Okay, right, so sorry, plus 1. Okay, so let's say times 12. Okay, so I got a value of 11.007. So that's 11% essentially, right? Okay, please just verify that for me. Okay, I got that 1.0072. Okay, and we said minus 1. In fact, I think I might have done something incorrectly there. So let's say shift again, the 6th root. So we said the 6th root of, okay, 19,319 and 48. And in this case, we said divide this by 18,500. Okay, so we got the answer. We said minus 1. Okay, and in this case, that gave us that answer. And we wanted to say multiply that answer by 12. Okay, yeah, I see that this is going to give me a bit of a problem. Yeah, let's say multiply that by 12. Yes, there we go. So I get an answer of 0.087. Okay, now remember, ladies and gents, that whenever I take interest rate, right, that's I over 100. Okay, so in this case, it means that the R value in percentage terms, so I just simply multiply that value by 100. Okay, so what I do on the left, I do on the right. So that means that I'm going to take that value multiplied by 100, and what will I get? So R is 8.7%, right? So that is our interest rate on an annual basis. Right, so the next question, they say calculate the effective interest rate. So remember that this is what we would refer to as the nominal interest rate, right? So what do we do? The interest rate, so 6.1.2, right? The effective interest rate, so that's 1 plus I effective is equal to 1 plus, right, I nominal, okay, divided by n, okay, all raised to, well, to the power n. And remember that n in this case becomes the compounding cycle per year, per annum, right? So I'm looking for the effective interest rate. Okay, I effective, right? This is going to be 1 plus, my nominal is 8.7%. So this is 0.087 divided by 12, right? And in this case, that's raised to the exponent 12. Right, let's get that effective interest rate quickly. Right, so it's going to be that entire bracket. So that's 1 plus 0.087 over 12. Okay, this is yx. Okay, 12. Right, we get that answer there. And I'm going to say minus 1, right? Because of that 1 that's on the left-hand side over there, right? And so my effective interest rate in this case will be 0.09, right? But of course, if I want to write it in percentages, I just simply multiply that by 100. So that would mean that if I take that value multiplied by 100, that will give me 9, well, we can say 9.06%, shall we? Okay, right, so that's my effective interest rate. Okay, right, I hope that makes sense, ladies and gents. Right, so they say to us, the next one, they say Kuda bought a laptop for 10,000 on January the 31st in 2019. He will replace it with a new one in 5 years' time on the 31st of January 2024. Right, so they say the value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. Right, they say after how many years will the laptop have a value of 0 rands? Okay, so remember when we talking about the straight line method, okay, you must just keep in mind that the straight line looks like our simple interest formula, right? So that's 1 minus, in this case, I times n. Okay, so our laptop was 20,000, is it? Okay, 10,000 rather. So that's 10,000 into, that's 1 plus. Now the interest in this case, or in the depreciation rate, is 20%, so that's 20 over 100. Okay, so this would be 0.2 multiplied by n, right? And what should it give us? It should give us a value of 0. Okay, so what are we effectively going to have? So if we divide by 10,000, right, that's still anything, 0 divided by anything still becomes 0. And so what we've got on the side, sorry, this was supposed to be minus. Okay, so I'm going to have 1 minus 0.2n, and if I take the negative 1 to the other side, it becomes negative. That's minus 0.2 times n, and if I divide both sides by negative 0.2, I get n to be equal to 5. So after 5 years, the laptop will be worth absolutely nothing. Okay, right. So in this case, they say to me, right, Kuda will buy a laptop that costs 20,000 rands in order to cover the cost price, right? He made his first monthly deposit into the savings account on the 28th of February, right? He will make the 60th a monthly deposit on the 31st of January, right? They say the savings account pays interest at 8.7% compounded monthly, right? And we must calculate Kuda's monthly deposit into the account, right? Now, ladies and gents, I want you to note in this case that Kuda, they said to us he will make his monthly deposit, his 60th monthly deposit, right, on the 31st of January, right? So that would have been 60 months exactly, right? In this case, he wants to buy the laptop. In order to cover the cost, he made rather a monthly deposit into the savings account, right, notice this, on the 28th of February 2019, right? And of course, until the 31st of January, he keeps making those deposits on a monthly basis. So now, what are we going to do? We're going to now say, well, look, in this case, we are looking for a future value, right, of 20,000 rands, right? We want to find out how much must he deposit, right? So what is our future value formula? So this is 6.2.2. Okay, so 6.2.2, our future value formula, remember we say this is going to be x into, right, that's going to be 1 plus I, all right, exponent n minus 1 divided by I, well, we can say I over m, right? All right, so we might as well do that. Okay, so divided by I over m. Right, so in this case, we want to know what will be the future value. Our future value should be 20,000 rands. Want to know the monthly deposit. Okay, so that's 1 plus. Our interest rate is 8.7%, so that's 0.087, right? That's compounded monthly, right? This is over 60 months. All right, so minus 1 divided by, right, 0.087 over 12. Okay, right, so remember that those are the monthly installments that he is making, right? So now let's calculate what will be the value of x in this case, which is the monthly deposits. So that's going to be 20,000, okay, multiplied by 0.087 over 12. Okay, so I get that value over there. right? And I am going to divide. So divide this by that bracket there. So that's 1 plus, again, 0.87 over 12, right? And that's yx 60. That's over a period of 60 months, right? And that's minus 1. Okay, so let's close that bracket. And what do we get? So he must make a monthly deposit, X in this case, I find it to be a monthly deposit of 267 Rand and 26 cents into that account on a monthly basis so that he will be able to make that purchase. Okay, right, so that is how the cookie crumbles, ladies and gents. Right, and then let's look at the last question. They say Tino wins a jackpot of 1.6 million, right? He invests all his winnings in a fund that earns interest at 11.2%, right? Compounded monthly. Okay, so he withdraws 20,000 from the fund at the end of each month. His first withdrawal was exactly 1 month after his initial investment. How many withdrawals of 20,000 will Tino be able to make from his fund? All right, now, ladies and gents, so whenever we are making a withdrawal, this tells us, so if you look at Tino's situation, right, so we've got a present value of 1.6 million, okay? All right, so we've got a present value. So we're going to make withdrawals of 20,000. So I'm going to use my present value formula. Say, well, present value is X. Those are monthly withdrawals. That's 1 minus, that's 1 plus I, that's minus N. Okay, and this is divided by our I. Right, so in this case, I know this is 1.6 million, right? 1.6 million, and we want the value of X, rather our value of X is 20,000, okay? And this is 1 plus, I think it was 11.2% if I remember. Yes, it is. Right, so that would be 0.112, that's divided by 100, isn't it? So divided by, so that's 12, that would be on a, that's our interest rate in this case, right? Compounded monthly, and this is divided by 0.112 over 12. Okay, right, now ladies and gents, we just need to be to make sure that we get this correctly, right? So first of all, I'm going to take my 1.6 million. Okay, now that's 16 million, so let's delete the 10. Okay, and I'm going to multiply it by that fraction over there, 0.112, okay, over 12. And in this case, I'm also going to divide it. Okay, so going to divide all of that by 20,000. Okay, right, so now I've got all of that. Okay, and remember, I still have that entire bracket inside there, right? But if I've now cancelled this, I've divided by the 20,000, I've multiplied by that. Do you see we've got that 1 there, right? So you'd have this only that is left because we've already divided by the 20,000 and we've multiplied by that value. So we've got this 1 over here. If I take it to the other side, it becomes -1, okay? So I'm going to take that entire value minus 1. I get negative 0.53, right? And in this case, I'm going to start introducing my logs. Okay, right. So the log of that value over there, okay, right, is equal to minus n, the log of 1 plus 0.112 over 12. Okay, right, so let's take that value there and say, all right, we've got that value, the log of our answer, okay, putting it in a bracket, right, divided by, okay, so my computer is complaining already. Okay, so that's divided by the log of, that would be 1 plus, that fraction is 0.112 all over 12. Okay. Right, ladies and gents, I get n. Right, so remember we've got minus n there. So minus n gives me minus 147.79. Okay. Right. So what would be our answer? Remember, that's in terms of withdrawals. Okay, so there's no 0.79 of a withdrawal. So therefore it means that the number of withdrawals that he will be able to make is 147 withdrawals in total. Right, and that is really how the cookie crumbles. And please get yourself familiar with these kind of calculations. Right, ladies and gents, let's move on to the next question. All right, and off to question 7, our dear friend calculus. Right, so we start with 7.1. They want us to find the derivative from first principles, and they've given us f of x, which is minus 4x squared. Right, so in this case, what you will always try to do, find f of x plus h, which is minus 4 into x plus h squared, right? So if we work it out, this is going to be negative 4. Right, now remember inside the bracket you've got x squared plus 2xh plus h squared, right? So essentially that becomes minus 4x squared minus 8. Okay, for negative 4 times 2, that's minus 8xh minus 4h squared, right? So that is what we get from that. So we're going to say, right, to find f prime, we take the limit as h tends to 0 of f of x plus h minus f of x divided by h, right? So I'm just simply going to substitute there, h tends to 0, right? My f of x plus h, we've already established that that's minus 4x squared minus 8xh minus 4h squared, right? This is minus f of x, so that's minus a negative 4x squared. Okay, and this is divided by h. Now notice in this case, negative times a negative, right, over there will give us a positive. So just in the interest of time, I'm going to change that to becoming a positive. And so what happens? It actually cancels out. Okay, so we can take out h as a common factor. So limit as h tends to 0. Right, so we are going to have, if I take out the h there as a common factor, that's going to be negative 8x, right? So that's minus 4h. Okay, right, and this is divided by h, right? So we've got those two cancelling each other, and now we can substitute inside of the equation, right? So we've got minus 8 of x minus 8x minus 4 times 0, okay? And of course, what are we left with? Minus 8x, and that is the derivative. Right, so let's go to the next one. Right, so we've got, they say determine f prime if f of x is 2x cubed minus 3x. So for 7.2.1, okay, so we've got f of x is equal to 2x cubed minus 8x. Okay, let me just make sure. Minus 3x rather. Minus 3x. All right. And now we're looking for f prime. So remember, we use our differentiation rules. This jumps down. So 3 times 2 will give me 6. Okay, minus 1. So that's 6x squared. Minus, in this case, remember there was a 1 there. That's minus 3. 1 times 3 gives me 3. And 1 minus 1 will give me 0. And anything to the power 0 is 1. So that becomes our derivative in that case. So 7.2.2, right? We've got that complicated expression over there, right? So we've got d of x. Okay, I think we've got a cube root over there of 7, that's 7 cube root of x squared. That's 7 cube root, 7 times the cube root of x squared, right? And this is plus 2x exponent 5. That's minus 5 rather. Okay, now before you remove this dx, right, please don't remove it until you've gotten rid of every bracket, right? Gotten rid of x in the denominator and gotten rid of all the surds, right? So in this case, this becomes 7x, right? Note in this case, the surd rather becomes 2 over 3, right? Plus, in this case, we've got 2x minus 5. Right, now we've got none of that, so we can find the derivative with respect to x, and what does that give us? It will give us, okay, so that's 2 over 3, right, multiplied by x, multiplied by 7. Okay, so 7 times 2, that's 14, so that will give us 14 over 3. X into, now 2 over 3 minus 1, okay, will give us 1 over 3, okay, plus, minus, because 2 times negative 5 will be minus 10, x minus 6. Right, and that is our derivative with respect to x. And so we look at the last question. So they say, for which values of x will the tangent to f of x equal to minus 2x cubed plus 8x have a positive gradient? Okay, right. Now, in this case, I want you to please note, we are looking, our value or our question is on f of x. So f of x is minus 2x cubed plus 8x. Am I correct? Okay, yep, that is exactly what it is. Right, now notice, what type of a graph would this be? It would be a, it would be a cubic function with a being less than 0. So that means that it has a minimum and a maximum. Now, where is this graph? Where is it going uphill? So essentially, we're looking for values of x where f prime of x should be greater than 0, right? So where is this graph going uphill? Okay, I always explain this as going uphill, right? And there I am erasing my graph. So where do I have an uphill? That's between that value and this value, right? This is where my graph is going uphill. So I'm going to have to find the x value of the turning points, and that would be my solution, isn't it? Okay, so how do we find the turning point? So we're going to say f prime of x, right, equal to 0. So this would be minus 6x squared plus 8 equal to 0. Okay, and we try to solve as quickly as possible. 6x squared is equal to 8, right? If I take that to the other side, becomes negative, but a negative and a negative cancel, right? So I can divide both sides by 6. Okay, so I've got x squared, 8 over 6, that should give us 4 over 3, right? And x will be the square root of plus minus the square root of 4 over 3, plus minus the square root of 4 over 3. Now, or you can say this is 2 over square root 3, right? Okay, so that means this x value here would be minus 2 over root 3, and this x value here would be 2 over root 3. So our answer is x must be, in order for our derivative to be positive, it will be positive for x is an element of, right, that's negative 2 over root 3 as well as 2 over root 3. Okay, right, and that is how we will get the values of x where our gradient is positive. Right, as we go on to the next question. Right, and off to question 8 we go. Right, so we've got for 8.1, they say we've got f of x, which is minus x cubed plus 6x squared minus 9x plus 4. And they've taken the liberty to, find the factors for us. And they say determine the coordinates of the turning points. All right. Well, I can already tell you that one of the turning points will be at x is equal to 1, right? Remember that when we've got a point repeating like that, then it means that it's not only just an x-intercept, but it's also a turning point, right? Okay, so let's find the other values. So remember, for the turning point, we take f prime. So this is going to be minus 3x squared plus, this is 6 times 2, which is 12x, minus 9, and this is equal to 0. Right, so this is going to be, right, we can divide actually every every term by negative 3. I think that should be fine. So we'll get x squared, right, minus 4x, right, please be very careful. So that's plus 3. Okay, this is going to be equal to 0. And if we factorize, factors of 3 are 3 and 1, and that's going to be minus and minus. So that is x minus 3, x minus 1, and this is equal to 0. X is equal to 3. Guess what? There's our friend there. Or x is equal to 1. So those are our turning points, right? They said determine the coordinates of it, right? So which means that we also need to find the y value. Now, please remember, for the y value, I'm going to substitute into the original equation. So I'm going to take f of 3 as well as, now I'm going to take the one that's, okay, so x minus 1 all squared. Okay, I'm going to take f of x, the one that they've simplified. It's minus 1 all squared, and this is minus x plus 4. I think that's what we got there, right? So if I take f of 3, that would be 3 minus 1 squared and minus 3 plus 4. Okay, and the other y value, that's f of 1. Okay, that would be 1 minus 1 all squared, as well as, I already know that it should be the y-intercept, right? That's into minus 0 plus 4. Okay, so this would already give us 0. All right, and the other one, so we've got 3 minus 1, which is 2 squared, right, times 1, so that should be 4. So we've got a turning point at 3 and 4. So that's our turning point, as well as at 1 and 0. Okay, right, of course, this one is the first one, and that's the second one. All right, now, ladies and gents, the next question is draw a sketch graph of f, clearly label all intercepts with all axes and any turning points. All right, so I already know that I've got, in this case, remember for my x-intercepts, so f of x, we said this was equal to x minus 1 all squared and minus x plus 4. That's equal to 0, right? So we know that x will be equal to 1, or in this case, x will be equal to negative 4, right? So because that will be minus 4 plus x equal to 0, and so x will be equal to negative 4. All right, now, ladies and gents, let's quickly have a look. So we know this one not only becomes the turning point, but it also becomes our y-intercept, our x-intercept rather. Okay, so y-intercept in that case simply becomes 4. Remember that this value here, okay, gives us the y-intercept. So we know this guy already tells us that our y-intercept is 4. All right, now let's try and draw this graph. Okay, so going to have x and y. Right, so I know that I've got, first of all, my x-intercept at negative 4. Okay, I've got another x-intercept at 1. All right, so, okay, let's do this. That would be 1. Okay, right, now note, I know the shape that this graph is going to have must be this kind of a shape because our a value is negative, right? And what else do we know? We know the turning point, right? So we know we had a turning point at 3 and 4. So we've got when x is 3, right? So there we've got a turning point at 3 and 4. X is equal to 3. Okay, and all right. Okay, something is not make sure here. Right, so our all right, so x is equal to 3, x is equal to 1. Okay, are we clear about that? Right. And then we've got at 0, 1 and 0, we've got our turning point over there, right? Okay, so we've got at 1 and 0, so there it is. So that should give us our other turning point over there. Okay, right, so we said our x-intercept would be at negative 4. Actually, I made a mistake. Yeah, I can see that actually. So that's x is equal to 4. Yeah. All right. That's why I was saying is not make sure. All right. So that would be at, that's 3 and 4. That's our turning point. This guy is 4 over here. Right. And we've got our other turning point. Okay. And we said our y-intercept is at positive 4. So I'm going to have the graph continue. Okay, just wanted to make it a little bit more neater. Okay, so, oops. Okay, so I'm not going to try and make it neat anymore. Okay, so that's what our graph looks like. Okay, right, so, yeah. So, this value here would be 4. That's y. And that's x over there. This value here would be 1 and 0. That's 3 and 4. All right, ladies and gents, there's our graph. Right, moving to the next question. They say to us, use the graph to determine the values of k for which minus x squared plus 6x squared plus 9x plus x equal to k will have 3 real and unequal roots. Right, now I want you to please note, at the moment when we look at our graph, right, we only have 2 roots. Where are those 2 roots? So our 2 roots are going to be this guy here and that guy over there, right? But they want us to have 3 real roots in this case. So which means we can shift, the moment we shift the graph down by any value of k, right, less than 0, okay, so meaning any negative value, right? And in this case, the maximum we can do is we can shift it 4 units down, because once we shift it 4 units down, in this case, that value would now be sitting there, and we don't want that situation. We want to have 3 real roots, right? So which means that k must be any value, right, from, in this case, 1, rather from 0, right, greater than 0, but it must definitely be less than 4. Okay, now keep in mind that if you are going to take k over there, right, to the other side, it would say minus k, right? And remember, we're already shifting it downwards. So that is why I am actually taking positive values, because we already have a negative over there. Right, so which means that k, right, must be any value. So k should be an element of, okay, just for consistency, keeping to the same color, right? So k must be an element of 0, must be greater than 0, okay? It must not be 0, but it must be less than 4, okay? Right, it must not be equal to 4 either. So in this case, you can write it in inequality form and say k must be less than, not less than or equal to, it must just be less than 4 and greater than 0. Okay, so that's shifting the graph downwards. All right, guys, let's go to the next question. They say the line g of x, which is ax plus b, is the tangent to f at a point of inflection of f. Determine the equation of g. Now, first we need to determine what is our point of inflection. 2 ways of determining the point of inflection, right? We can say that it is the midpoint, so I'm looking for 8.4. So we're doing 8.4. Remember, this was 8.3 here. Right, so the point of inflection in this case, ladies and gents, I can either take the double derivative of x, right, and make that equal to 0, right? Or I can take, in this case, the midpoint between my turning points, right? And I'll show you, you do get to the exactly the same answer. Our double derivative, right, would be minus 6x plus 12. So that's minus 6x plus 12 is equal to 0. And so our point of inflection, minus 6x is minus 12. If I divide by minus 6 on each side, right, then x would be equal to 2. And definitely that would be the midpoint between 1 and 3, isn't it? Okay, so now what would be the y value there, right? Because we do need the y value at that point. So this would be f of, now remember I said to you, I'm going to take the one that is already simplified. So that's minus x plus 4, right? So f of 2, that's 2 minus 1 squared. That's minus 2 plus 4. Right, so in this case, what's my corresponding y value? 2 minus 1, that's 1, squared, that's 1, right? And negative 2 plus 4 gives me 2, so that will give me 2. F of 2 is 2. Right, so now, which means that we've got our point of inflection, right? So point of inflection would be where x is 2 and y is also 2. So what we're going to do is we're looking for the derivative, right? In this case, at x is equal to 2. So f prime, right, that will give us the gradient. Okay, we said our f prime is minus 3x squared plus 12x minus 9. Minus 3x squared plus 12x minus 9. And we know in this case we're looking for the derivative where x is equal to 2. So that's minus 3 times 2 squared plus 12 times 2 minus 9. Okay, right, please help me get the right answer there. So that's minus 3 times, that's 2 squared, plus 24, that's minus 9. Okay, so I get 3. So which means the derivative at x is equal to 2 is 3. So our equation is y is equal to 3x plus c. Now to get our y-intercept, I'm going to substitute the point that it passes through, right? I know that when y is 2, okay, x is also 2. And so that will give us 6. 3 times 2 is 6. If I take that to the other side, 2 minus 6 will give us negative 4. So c is equal to negative 4. So our equation is y is 3x minus 4. All right, so that is how the cookie crumbles, ladies and gents. Or they said we need to write it in the form g of x, right? So which means g of x is 3x minus 4. Right, now for the last question. They say calculate the value of theta, the acute angle formed by G, and the x-axis in the first quadrant. All right, that's quite simple, right? So we know that, okay, so this is our last question, that's 8.5. Right, so we know that m is equal to the tan of theta, right? So m is the gradient, so that's 3 equal to tan of theta. And to get the angle theta, that's the arctangent, okay, of 3, right? So shift 10. Please make sure that your calculator is in degrees, okay? So that will give us, so that acute angle would be 71.5, well, let's say 57, right? So that's 57. Okay. Right, so that is how question 8 ends, ladies and gents, and we'll be off to question 9. Right, question 9, and off to a closing this out. They say the diagram below represents a printed poster, rectangle ABCD, right, which is is a part on which the text is printed. The shaded area ABCD is 432 square centimeters, and AD is equal to X centimeters, right? So AD, we might as well just show that there. So this guy here would be equal to X, okay? And they say ABCD is 4 centimeters, or rather ABCD is 4 centimeters from the left and right edges of the page and 3 centimeters from the top and the bottom of the page. Okay, so this is what we are seeing there. Right, and they say to you, show that the total area of the page is given by that formula over there. Now, ladies and gents, I want you to please note, right? So remember what we're given. We're given the shaded area, right? They've told us that it's given by that value there. Right, now, if we say that this is going to be length multiplied by the breadth, okay, I'm going to call that breadth y there, right? So that is x times y. Right, so I want you to please notice in this case. So we know in this case now, they said to us the total area of the page, right? So we're looking for this entire thing over there, right? So this is telling us that if we were to look for, so if I look at that, this is going to be y, right? So this is y over there. Plus, in this case, do you agree with me? This is 3 centimeters and another 3 centimeters. So this guy here is y plus 6. Okay? Whereas, if I call this x, all right? So, there's our x value here. All right, and between our x's, I've got 4 and 4. Apologies about that. So I've got 4 and 4. So in this case, which means that x times y, the shaded area, you remember they told us, right, is equal to 432. So let's try and do that. So first of all, I'm going to say, well, the area of ABCD, which is a rectangle, that's length times breadth. Okay, so let the length be equal to x and the breadth equal y. So that means this will be x multiplied by y. But notice in this case, it means x multiplied by y should be equal to 432, right? 432 centimeters cubed, right? So I can actually make y the subject of the formula and say, well, y is actually 432 over x. Right, so this would be my first equation. Now let's take the entire area now, right? So the total area in terms of, okay, let's just take the area first. Okay, they want it in terms of x, but it's going to be in terms of x and y for now. So the total area, now you remember I said to you, if I look at the length, that was y plus 6, right? So the length, sorry, the breadth is y plus 6. The length would be x, so that's x over there, plus 4 and 4 on this side. So for this side, for this side. So that's x plus 8. Do you agree with me? Right? So in this case, this would be x plus 8, right? So to get the total area, it would be x plus 8 multiplied by y plus 6. Okay. So the total area, again, length times breadth, would be x plus 8 times y plus 6. Okay, I hope that makes sense, ladies and gents. Right, but I remember what is my value for y. Okay, that's 432 over x. Actually, let's substitute that later. So if I multiply this throughout, this will be x times y plus 6x plus 8y. That's plus 8 times 6. Right, my mind is not working as sharply now. I've been busy for the longest time. 48, right? So plus 48. Okay, right, now I can substitute for y. So let's call this equation 2. So let's substitute for y equal to 432 over x in equation 2. So which means a in terms of x will be x times 432 over x, right? So that's y there, plus 6x plus 8, our y value, 432 over x, this is plus 48. All right, so ladies and gents, I'm sure you can see this and that cancels out. This gives me 432 plus 6x, 8 times 432. So that's 8 times 432 gives me 3,456. It's 3,456 over x, right, plus 48. And finally, right, let's add all our like terms. So I've got 432 plus that 48 there. Okay, I think this will give me 480 plus 6x plus 3,456 over x. So that is the area in terms of x. I'm sure you can see it, ladies and gents. Okay, so they've just written it the other way around, but it is exactly the same thing. Right, so they say to us, determine, sorry again, right, determine the value of x such that the total area of the page is minimum. Now, we've got a formula for area, right? In this case, we know that we want to minimize. So what are we going to do? Take the derivative and make it equal to 0. Right, what is our derivative? The 480 falls away, right? So that will be 6 minus, now notice in this case, actually, let's write a of x first. That will be 3,456, 3,456 x minus 1 plus 6x plus 480. And so if I take the derivative, make it equal to 0, that will give me minus 3,456 x minus 2, right? X minus 2, sorry about that, plus 6, and this would equal to 0. So if I take this to the other side, though, so that's minus 3,456 over x squared is equal to negative 6. And of course, I can drop down the negatives by multiplying by negative 1. So I've got 6x squared equal to 3,456. Okay, 3, 4. 3, 4, 5, and 6. So divide that by 6 and take the square root. Okay, so in this case, I'll only take the positive number, right? So this would be the square root of 3456 divided by, this is divided by 6. And I get x is equal to 24, right? And please remember that that is centimeters, right? Because my area was given in centimeters squared. So this means that x would be 24 centimeters. Right, I hope that makes sense, ladies and gents, as we move on to the last question. And finally, we are at question 10, ladies and gents, and let's get right into it. Probability, our favorite section, right? So they say 10.1, A and B are independent events, right? The probability of A is 1 over 3. The probability of B is 3 over 4. Determine the probability of A and B. Now remember, ladies and gents, I made that very easy video on probability, right? So I said to you, when you want the probability of A and B for independent events, any independent events, we know that for independent events, probability of A and B will be equal to probability of A times the probability of B, right? Now, we're looking for the probability of A and B in this case, so that means this is going to be 1 over 3 multiplied by 3 over 4. And so that will give us 3 over 12. And if we want to simplify it, we can say the probability of A and B would be equal to 1 over 4. All right, so 10.1.2. They say probability that, determine the probability that at least one event occurs. Now remember, when we say at least one, so it would be at least either A or B, right? So what are we looking for? We're looking for the probability of A or B. So probability of A or B. Now remember, our golden rule in probability says the probability of A or B will be probability of A plus the probability of B minus the probability of A and B. Okay, please remember this golden rule of ours. Okay, it will always save you in this case. So probability of A, we said that's 1 over 3. Probability of B, we said this was 3 over 4. And the probability of A and B is 1 over 4. All right, and we can calculate that. Okay, so that will give us 1 over 3. So that will be 1 over 3 plus 3 over 4. And this is minus 1 over. That's minus 1 over 4. Okay, so we get 5 over 6. Right, so we get that probability to be 5 over 6. Right, and that is how we're going to do that one. Right, as we look to the next one, they say to us, so I actually just separated them because they had to do with three different things. So the probability that it will snow on the Drakensberg is 5%. When it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 72%. Right? If it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 is 35%. Right? Now they say represent the given information on a tree diagram, clearly indicate the probabilities associated with each branch. Right, now ladies and gents, I just want to make some more space here. Now I want you to note, so in this case, which means that the temperature's dropping depends on whether it it snows on the Drakensberg or not, right? And they said to us the probability that it will snow is 5%, right? So there are two possibilities here. So first of all, the possibilities of snow, right? And what the outcome of the snow will determine will be the temperature in South Africa. Okay, right, so I'm gonna do that. So let's first represent the probability of it snowing, right? So the probability that it will snow, okay, will be 5%. We said, well, that's 5%. Okay, meaning that the probability that it will not snow is actually 95%. Okay, right. Now, if it does snow, ladies and gents, right? So there are two possible outcomes, right? The probability of sub-0 degrees temperature, meaning the probability that it might be below 0 degrees. Okay, so I'll say the probability of sub-0. Okay, so that probability, they said, if it does not snow, okay, they started with not snowing. Okay, I'm going to start there. All right. I said if it does not snow, the probability, no. Actually, they gave us when it snows, the probability that the minimum temperature South Africa will drop below 0 degrees is 72%. So the probability now in this case of getting sub-0 degrees if it snows is 72%, meaning that the probability that it will not go sub-0 is what's 100 minus 72? That should be 28, right? So that would be 28%. So remember, we are using a complementary rule because this plus that must give us 1, as well as this plus that must give us 1, right? So if it does not snow, the probability of sub-0, in this case, they said the probability that the minimum temperature will drop to below 0 is 35. So if it does not snow, the probability is reduced to 35%. And of course, the probability that it will drop to sub-0, in this case, should actually be 65%. Okay, right. Now, that is how we'll represent it in terms of a tree diagram. Okay, now they say to us, represent the given information. Okay, we've already done that. They say calculate the probability that the temperature in central South Africa will not drop below 0 degrees in June, right, in 2024. So now there are two things that will affect it not dropping below sub-0. Now I want you to see there are two parts that we're going to follow here. Firstly, it will be if it does snow, right? If it does snow, right, what are the possibilities that it will not drop below? So it will be that guy there. Sorry, I was supposed to say P subprime there, just to show that this is not sub-0, right? So that is not sub-0, but also if it does snow, then if it does not snow rather, there's the probability that we will drop to sub-0. Right, now, how are we going to calculate that entire probability? Right, so the probability of dropping below for sub-zero sub-0 degrees Celsius, okay, will be, now 5%, remember this is 5 over 100, so this is going to be 0.05, okay, so it's this guy, multiplied by that probability, multiplied by 0.28, okay, plus rather, so I'm gonna add the blue, the red and the green, plus 0.95 multiplied, so that's 95%, multiplied by 0.65. Okay, so that's how I'm going to represent it. Okay, so that's 0.05 times 0.28 plus 0.95 times 0.65. Okay, and so that means that the probability of that would be 63.15%, or you can say that answer that I've got there, that's 6.6315. Okay, right, and that is how you're going to represent that, ladies and gents. Okay, so let's go on to the very next one. So this is fundamental counting principles. So let's say we've got 10 learners that stand randomly in a line, one behind the other. Okay, so I always like representing my data in this case as, you know, just some rows there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, let's make this one a little bit nicer. Okay, right. So in this case, I've got all of those, right? So they say to me, in how many different ways can the learners stand in line, right? So if you think about it, right? So we've got 10 positions in this case. We've got 10 learners, right? So in the first position, of course, I can place 10 of them. The second position, right? I've already placed 1. So I can place 9. The second position I can place 8 because I've already placed 2. And the fourth position I can place 7, right? Now because I've already placed 3, I've got 7 to choose from, and so on and so forth. You can see how that one will give us the factorial, right? So that's 2 and 1. Right, so that means that for 10.3.1, ladies and gents, that gives us, that would be 10 factorial, right? Okay, so that would give us, okay, you can calculate there, what is 10 factorial? That's 3,628,800. All right. And then 10.3.2. Now they say to you, calculate the probability that there will be 5 learners between the 2 youngest learners in the line. All right. So here we are. Okay, I'm going to use the very same one that I've got over there, and I want you to look at these possibilities, ladies and gents. Right, so let's say I've got 2 youngest learners, and I'm going to indicate them in a blue color, right? So if I place the youngest 2 learners, let's say I place the first one in position 1. Remember, there's 2 of them. So in position 1, so meaning that I can choose between the 2 of them in position 1, but now there must be 5 other people in between, so which means I can place the other one in position 6, right? So that's 1, 2, yes, that's position 6. So I can now place the other one in position 6, right? Now I've placed 2 learners. How many are left? That would be 8. So that would be 8 factorial in that case. So in that case, you can look at it. I can place 8 here. I can place 7. I can place 6. I can place 5. I can place 4. I can place 3, 2, and 1. So that would be 8 factorial, right? But now, please, I want you to also look at it again, right? So again, I can do the same thing, right? But this time I can place my youngest learner in position 2. Okay, so if I place my youngest learner in position 2, okay, so I said I'm going to indicate them with the blue color. So here's the first position, right? So I can place the other one, 1, 2, 3, 4, 5. Okay, I can place the other one there, right? So in that case, what happens again? I've got another 8 factorial, right? So that's 8, 7, 6, 5, 4, 3, that's 2 and 1, right? But again, what can I do, ladies and gents? Put the youngest learners, okay, in position 3. If I put the first one in position 3, right, I said I'll indicate them with the blue color. So I can put the first one in position 3, but remember, for the first one I have 2 to choose from, right? Once I've placed the first one, then I've got only 1, so that's 1, 2, 3, 4, 5. Okay, so that means I can place the other one there, right? So again, plus the factorial again, right? So in this case, the last position that I can place them in so that there's 5 people in between is if I place the 1 in position 4. So that's 2. So that means the 1 would be, that's the only way I can have 5 learners in between, right? So in that case, I've got, all right, so that's 8, 7. Okay, let's use the yellow color. All right, so that's 8, 7, 6, 5, 4, 3, 2, and 1. Right, now, ladies and gents, I've shown you 4 possible outcomes, right? So in this case, for each one of them, we've got 2 multiplied by 1 multiplied by 8 factorial, right? So, and I showed you 4 of them. So which means I've got 4, right? Wherein I'll have 2 multiplied by 8 factorial, right? So in that case, that is the number of possible outcomes wherein I will have 2 of the youngest learners in between. But now they said calculate the probability, right? So remember, when I calculate the probability, this should be divided by the total outcome, and in this case, that is 10 factorial. And so for our final answer, we will say, well, this is 4 times 2 times 8 factorial, 8 factorial, okay, and all of that divided by 10 factorial, right? Okay, so I get 4 over 45, right? So that's the answer that I will get. So that is the probability. And ladies and gents, I hope that did make perfect sense to you, right? And I shall leave it there, right? I hope that you were able to follow on from the beginning when I started with this paper. And I wish you all of God's best as you do your final exams, right? Otherwise, from me, I'll see you again next time. Sharp, sharp.